Good morning and welcome to your next comp sci video. Um, in the last notes, you learned a little bit about matrices, and this packet is going to go through some questions on matrices. Some of these are kind of difficult, but they at least get you the idea of how matrices work and what the code looks like when you use them. So the first question, which says 31, which of the following initializes an 8 by 10 matrix with integer values are perfect squares? 0 is a perfect square. Okay, so number one, when you see int bracket mat equals new int 810, you've got an 8 by 10 matrix. Remember, that's rows by columns. And if it doesn't initialize it to anything, you saw this a couple weeks ago with arrays. Do you remember what that initializes everything to? Everything's initialized to 0, right? So this right here, oops, you could say originally initialized to all zeros. So again, 0 is a perfect square, so that technically is a matrix with all integer values being perfect squares. So 1's good. Second one says int bracket mat equals new int 810, so we make the matrix. Then it has a double for loop. Whenever you see the double for loop, you should look at it quick to make sure it's set up correctly, but that usually means you're going through a matrix. R is the row, row 0. R is less than mat.length. That gets you through all of the rows. And C equals 0. C is less than mat bracket R dot length. This is going to go through all the columns. So remember how an array is set up. So each row has a set number of columns. So when R is 0, row 0 has that many columns. Then when R is 1, row 1 has that many columns. So this is essentially going to make the array do something like this. When R is 0, so here's row 0, column's going to start at 0 and go as long as, in this case, it'll go 0 through 9, since there's 10 columns. It'll go as long as there are columns, and at each spot, row 0, 0, R times R is 0. So this will be 0, this will be 0, this will be 0, they'll all be zeros. Then when row becomes 1, again, you're going to go through all of the columns in row 1. That's what mat bracket 0 dot length does. And this time you're doing 1 times 1 everywhere. R times R is 1. So this is going to be all 1s. So you can see how this is going to get through every value in the array, and it's going to always set it equal to a perfect square. And the last one, you make the array. The only difference is you go through the columns first and then the rows. Does it matter if I go through the columns and fill all of those, or if I go through the rows and fill all of those? Well, theoretically it doesn't, and there is a way to do that, but the problem with this is right here. It wants you to do mat bracket R dot length, but R only exists in this for loop, and this for loop doesn't exist at this section of the code. See, this one worked because R existed right here, so anything inside this for loop knew what R was. And this other for loop down here was inside it. Here it's backwards, so that doesn't work. So this will give you an error. So the official answer for this one is 1 and 2 only, which is D. Now you might remember from the last video, instead of putting R here, if I put a 0, so if I do mat bracket 0 dot length, and then C++, C equaling 0, row 0 is always going to be a valid row. So if I put any valid row in there, then this will go through all the columns and then all the rows, and this would have worked. But since that used R, we can't use it. Now the other thing, some of you might not like that there's no brackets here. It's technically okay to do no brackets inside a loop if there's only one thing inside the loop. Technically, this for loop only has one thing inside it, another for loop. And this for loop only has one thing inside it, this line of code here. So I would rather have brackets like you're used to, but it's technically okay to omit them if there's only one thing inside it. Okay, so anyway, that one was D. Next one, number 32. Consider the following method that will alter the matrix mat. Don't worry about words like static. Just think of it as public void, mat stuff. Okay, so it figures out the number of columns, and then it goes through the columns and sets something equal. Okay, so this is nice because we've got an example, and then they tell you that you're doing mat stuff, giving it this matrix, and sending it 2. So let's go through this knowing that row is 2. So num cols equals matrix bracket 0 dot length. So here's row 0. Number of columns is 4. So this is equal to 4. Starting at column 0, going through the number of columns. So you're going through all the columns, but you're setting matrix of row 2 and then whatever column we're at. So 2, 0, 2, 1, 2, 2, 2, 3, all of those are going to get set equal to row, which again, row is 2. So basically everything in row 2, this is row 0, this is row 1, this is row 2. It's going to go through all the columns in row 2 because this is just going through the columns. The row is constant, setting everything equal to 2. So it looks like it's going to be A. Okay, so again, just know what you're going through. Your row is constant, spanning all the columns. Okay, next page. Assume that a square matrix is defined by this. So I can make a square matrix by putting the same size both places. What does the following code segment do? Okay, so I'm seeing it go through I and J. It's swapping. Okay, so swap's another method. You may assume the existence of this swap method. What it does is it interchange matrix AB with matrix CD. So it's given a matrix. This is one spot, row A, column B, with another spot, row C, column D, and it swaps them. And this wants to know what it does. So this one's a little trickier than the last one because it doesn't give you a specific example, but it kind of does. If you look at all of these answers, each answer gives you an example. It looks like my example matrix, mat, is 2, 6, 4, 3. And if it didn't give you that example, I would have made one up. Okay, well, what size? Size is the number of rows and the number of columns. So it looks like that size equals 2 in this example, because there's 2 rows and 2 columns. So I is less than size minus 1. So if size is 2, what's size minus 1? So this is really like 1. Oops, let me write that better. And if I equals 0 and I has to be less than 1, when can I run? What could I be? Well, I can be 0, but once I is 1, it's already too big. So I is only ever going to be 0. So now knowing that I is 0 and size is 2, if size is 2, 2 minus 0 is still 2, minus 1 is 1. So this is always going to be 1 also. So if j equals 0 and j has to be less than 1, j can only be 0 also. So you're going to swap, you're going to send it matrix, you're going to send it 0, 0, and you're also going to send it size minus j minus 1, 2 minus 0 is 2, minus 1 is 1. And you're going to send it size minus I minus 1. Size minus 0, 2 minus 0 is 2, minus 1 is 1. All right, so kind of confusing, but at the end of the day, you're just swapping spot 0, 0 with spot 1, 1. So this is spot 0, 0. This is spot 1, 1. And it's going to swap them. So now it's going to look like 3, 2, and 4 and 6 aren't going to move. So it's not this one. Looks like this one reflects through its minor diagonal. I guess that's called the minor diagonal. And just double check, make sure nothing else matches. 3, 2, 3, 2, nope. Okay, so it's B. Again, would have been pretty tricky if they didn't give you some choices. Okay, over to this one. Now I'm going to read through this one, then I'm going to have you try to do it and see if you can figure out the answer. Square matrix is declared, so another size and size, so it's a square again. Consider the following method. This is called mystery method. It's giving you the matrix, an integer value, something that's called top left, something that's called bottom right. Hopefully those are named appropriately, but can't assume. It's got a couple for loops, changing some things in the matrix. It says assuming there are no out of range errors, what best describes what method mystery does. It places values in the corners of the rectangle with corners top left and bottom right. Okay, so here's a rectangle. It's saying it just places values in the corners of the rectangle with corners at top left, bottom right. So corners of the rectangle mean it has to be, there's top left, there's bottom right. It would need to do these ones also. So A would look something like that. B places values in the diagonals of the square with corners top left and bottom right. Okay, so this one would look something like this. Here's top left, here's bottom right. And it says it's placing values in the diagonal of that square. So maybe something like that. C places value in each element of the rectangle with corners top left, bottom right. So what's that mean? If this is top left and this is bottom right, it places elements or values at every element in that rectangle. So it would look something like that. D places the value in each element of the border of that rectangle with borders top left, bottom right. So if you had a border of a rectangle, remember a square is also a rectangle, just how I drew it. So it just has on all the borders of it, so nothing inside the rectangle. Then this last one places value in the topmost and bottommost rows of the rectangle. So the topmost row, bottommost row would look something like that. Okay, so there's all of what the cases are saying. Now your job is to pause the video, look through this code, and see which one you think it falls into. Okay, so I'm going to have you pause it and give that a shot. Ready to see it? Okay, let's run through this. So you know you've got a square matrix to start out with. Okay, so check at what's constant. So here, the rows are constant. And the reason the rows are constant is because they have top and bottom. Top and bottom are set values. They're not loop variables like I that are changing. So if the row is staying constant, let's say this is the top row, and this is the bottom row. The rows are staying constant, but I'm going from left to right. So let's say left is here, right is here. So I'm going from here to there, starting at left, going to right, and the I value is changing as I go here. It's setting it equal to whatever value. So let's say X is my value. So in top, starting at top left and going to bottom right, it's placing X's all across that row. Same with bottom. Bottom is staying constant, so I'm in this row. This is set, but my loop variable is changing starting from left, going to right, and making them all equal to whatever value I told them. Okay? Now in this one, the columns are constant. And if the columns are constant, that means you're going through those columns. So I is top plus 1. So I'm starting from 1 under what they tell me top, and I'm going to and including to 1 under what they're telling me bottom. So I'm going from the row right under top to the row right before bottom. So I'm going through all those rows in that column, in the left column filling it with value, and then in the right column filling it with value. So if you said choice D, that's what it's doing. It's going through all the borders of that rectangle. All right. Any questions? Email me if you do. Okay. I'll do the next one with you. Here's 35. This question refers to the following method. So it's a Boolean. So it's going to return a true or false. It's called is there. You're sending in a matrix. You're sending in a row, a column, and some symbol. All right, so looks like a lot going on here. We'll deal with that in a second. Now consider this code segment. So we've got a matrix, an 8 by 8 matrix, so it's a square matrix. Which of the following conditions on a matrix of the type declared will by itself guarantee that if I do this, so I send a 2, 2, and $, it'll have a value of true returned when evaluated. The element in row 2 and column 2 is the $. Okay, so here's my matrix. Here's 0, 1, 2, 0, 1, 2. If I know this one thing is a $, and nothing else, will that return true? What's this one? All elements in both diagonals are $. Okay, so it's an 8 by 8, so it means it goes 0 through 7. So if I know that all of the diagonals are $, all the way through, so same with this diagonal. Obviously this isn't perfect because I didn't draw the whole matrix out because I didn't want to draw it. Will that guarantee a value of true? And then the last one says if everything in column 2 is a $. So if all of these are $, all the way down to the last row. So we want to know which one or ones of these will guarantee I get a true out. Okay, let's see what's happening. Yes is a Boolean. It's not initialized to anything. We've got I and we've got count, and count is initialized to 0. We have a for loop. I is less than size, so it's going through all the rows or columns. If matrix bracket I bracket column, now this dot equals thing looks weird. That's sometimes how they check if strings are equal. So this is like saying if matrix bracket I bracket column equals symbol. You'll learn if you take AP, you'll learn why they have dot equals there, but it's kind of just another way to check if a string is equal to another string. Okay, so again, column is staying consistent, and we're sending it 2 for the column. So we can say this is 2. So this is saying I'm going through all the rows, going down column 2, and it's counting how many times the thing I'm looking at is equal to the symbol, which in this case is the $. So in this case, I'd get for sure $1. In this case, I'd get $2, one in each diagonal. In this one, I'd get $8. And yes equals if count is equal to size. So if count is equal to 8, if I have $8, yes is true. So in this case, yes would be false right now. In this case, yes would be false. And in this case, yes would be true because I have $8 and that's equal to the size. So far, yes only became true in the third case. Okay, now count gets reset to 0. I'm going through everything again, but this time it's the row that's constant. So I'm going through row 2 and checking how many times that equals the symbol. So here there'd be 1 time in row 2. Row 2 would have 2, 1 for each column. And row 2 would have 1 in this case. So this returns either yes, the value of yes, or if count equals size. So for all 3 of them, count will not equal size right now because none of row 2's have $8. So this is false for all of them. So the only way this is going to return true, that's what we're looking for, is if yes was true. If this is true or this is false, it'll return true. But if they're both false, it's going to return false. So the only one where yes was true was case 3, which means 3 only is your answer. All right. Okay. Just got 2 more and we are done. Okay. Number 36. A two-dimensional array of double rainfall will be used to represent the daily rainfall for a given year. In this scheme, rainfall month day represents the amount of rain on a given day and month. For example, if I send it rainfall 115, you'll get the amount of rain on January 15th. 1225 will give you the amount of rain on December 25th. The array can be declared as follows. So it's a double, and it's making it 13 rows and 32 columns. Why might they do that? Well, if they really want each row and column to correspond to a specific day, I need to have at least 31 days. So I need a row 31, or I guess a column 31, sorry. And I need at least 12 months. So I need a row 12. But to do that, 0 through 31 means I actually have how many columns, and 0 through 12 means I have how many rows. I have 13 rows and 32 columns. Okay? Because they have to start at row 0 and column 0. This is what this says. This creates 13 rows indexed 0 through 12, 32 columns indexed 0 through 31, all initialized to 0 initially, because I'm not setting it equal to anything, so everything's a 0. Row 0 and column 0 will be ignored because those aren't actual days. Same with column 31 and row 4. So that row 4 will have a column 31, but it's just going to stay 0 because there's no April 31st. When there's no leap years, row 2, columns 29, 30, and 31 would have to be ignored since those days don't exist in non-leap years. So the precondition here is that this rainfall is initialized with values representing amounts of rain on all valid days. Invalid days are zeros, and we're assuming it's not a leap year. Returns the average rainfall for the year. Okay, so it's got a total. Think about how you'd have to find the average. You'd have to add up all of the values in this array and divide it by the number of days. Which of the following is the correct representation for more code so the post condition will be satisfied? So if I start at month 1 and day 1, remember months are like rows, days are like columns. If I add the rainfall from that month and that day, will that get me the sum of everything in here? Well, yes, we're ignoring row 0 and column 0, but those should all be 0 since those aren't valid days. So this will give the correct total amount of rainfall. Is this the correct average? Well, if I really want the average for the year, that's not how many days are in a year. You need to take the total divided by 365, and 13 times 32 is going to be the number of spaces in this matrix, but it's not the number of days in a year. So that's not going to work. This has the exact same for loop, so I add up all the values in the matrix, because the only thing I'm missing are days that are 0, and it divides by total by 365. Now total is a double, so this is going to calculate it correctly. I don't need 365.0, so 2 works. And the only difference between 2 and 3 is I start at row 0 and column 0. Is that going to affect anything? Well, again, no, because row 0 and column 0 don't affect the totals because they're all zeros. So that works also. So it's 2 and 3. All right, we got one more. Who doesn't love a question that spans 2 pages? There's the question, there's the answers. So I think I'm going to read through it again and see if you can pause the video and try this on your own. Simple tic-tac-toe board is a 3x3 array filled with either X's, O's, or blanks. This is a class for a game of tic-tac-toe. Again, don't worry about things like private and static, things like that. All that you need to care about is that there's a string matrix that's called board. It has 3 rows and 3 columns. It'd be labeled 0, 1, 2, 0, 1, 2. Don't worry about what a constructor is. Basically, this just makes the tic-tac-toe board. So it makes the board with that number of rows, that number of columns. It sets them all equal to, since they're strings, it sets them all equal to an empty space initially. So this constructor, it's called, and then you'll learn more about that in comp sci, AP Comp Sci if you take it. Basically, it's just got blanks for a tic-tac-toe board, just spaces. This makes a move. So if it sends it a row and a column and an X or an O, it sets it equal to X or O. This toString method is supposed to create a string representation of the board. So if the board initially, if this is my tic-tac-toe board, and I have an O here, two X's, and an O, it's going to print this out. So it's going to print out kind of the borders and where the X's and O's are. So it's got this more code thing, so it probably means I'm going to be looking at that. Let's look at our choices. So which segment represents a correct replacement of more code in the toString method? So basically, you're looking at what goes here. You're trying to make this board. So when you see S equals S plus, it's adding that on to S. What was S? S was initially just an empty string. Okay, so if I've got an empty string and I keep adding on these next things to it, my goal is to get a border and then anything that's in that row and another border, and then the next border and anything that's in that row and another border, and another border and everything that's in that row and another border. So your goal is to make it look something like this. See if you can figure out which option here will do that. So if you want to press pause again and look at your packet, get what you think. My one hint is going to be watch your details. Watch where those borders are going and things like that. Make sure you're getting it to look like what we want it to. All right, so pause and give it a shot. All right, let's see what you came up with. This goes through all the rows, goes through all the columns. So let's say when I'm at row 0, it's going to put a bracket on. Then it's going to put, here, let's use an example. Okay, something like that. So it's going to start, it's going to put a bracket, it's going to put whatever was in that row, 0. It's going to put another bracket, or line, I guess, and then it's going to do a new line. And then when column is 1, it would do a bracket, the X, and then another border line. This is what it's going to look like. It's going to just make it go down one by one. That's not what I want this to look like. So A is out. For B, it's going to go through all the rows. So in row 0, I first get a border. Then I add on what's in space 0, 0. Then I put another border and a new line. Then I would do space 0, 1, border, new line. Then I would do space 0, 2, border, new line. We started off good, but ended weird. Let me redraw the fake board. What I used before, whatever. Okay. Starting at row 0, I do a border line, and then I do what's in 0, 0, what's in 1, 1, sorry, 0, 0, 0, 1, 0, 2, and then I do the next row, so now row is 1, but it never did a new line. So then it just does row 1, 0, which is a space, and then row 1, 1, which should be an X. It's going to do it all on one line because there's never a new line anywhere here, so that can't work. Okay, now the way this is written with no brackets here, it's going to go through all the rows, but this for loop isn't inside this for loop. It's just going to do a line for all the rows, and then it's going to start all of this. That doesn't work. So this one better work. and it does. I go through all the rows. When row is 0, I do a line, and then this goes through all the columns. So I print out what's in column 0, 0, 0, 1, 0, 2, and then after that for loop's done, it does another border with a new line. Now row is 1. Draw a border line. Go through all the columns. 1, 0, 1, 1, 1, 2. This is done now, and it does a border line. You can see this is going to work. So E is your answer. All right, so that is the end. So hopefully that gave you some ideas how matrices work. I know it's still kind of a new concept for you, but the next step is going to be a little program that's going to deal with matrices. But for now, that's the end.